Good morning and welcome to Wheaton Wold Farm on the edge of the Yorkshire Wolds. This morning we've brought together a group of relevant people, I believe, looking at products, product formulations, but more importantly those who actually use them. So just a quick introduction to the people we've got involved here this morning. Probably most importantly is Mr. Charles Rook, whose farm we're on at the moment. Then we've got his spray operator and landwork foreman, Nick King. And then, probably a rarity in the 35 years I've been doing this job, I don't think this group have ever been brought together before. We've got a formulations chemist so that relevant people can ask questions between one another in the group when it comes to formulating products, what's expected of those products, and we can ask those questions with those people involved. Just by way of a general discussion then, and we're all aware of the different formulations that are out there in the way of you know, in the arena of the pesticide market. You know, we've got ECs, SCs, you know, and obviously, are you interested in those terminologies, or are you interested in what those terminologies mean? Charles, you at the end of the day sign the cheque for these products, so you want to make sure that what you're paying for is going to work on farm, do the job it's supposed to do. You know, have you ever sort of taken time to talk to your agronomist about these sort of different types of formulations?
I think historically, when you have a product that doesn't potentially mix very well, you don't want it again, but also is, you know, you might want something that's very similar. Yeah. So yeah, we do have a discussion with, you know, we didn't like that, but what else is there out there which does the same thing, but mixes a lot easier, especially for Nick. Yeah. You know, to be able to mix it. Yeah. Easier, and its compatibility with other herbicides, pesticides, or whatever.
Yeah. We're always conscious of the number of days we've got to actually apply the materials, and I guess, I don't know, I've always worked on the theory that we've probably got 7 or around 7 ideal spraying days throughout the year, Nick. We've discussed this in the past. Yeah. We want to make sure that those 7 days we're not messing about trying to get formulations out of a bottle. And Nick, you've used powders, you will have used SCs, you might not have recognised them as such, but taking those powders, putting them into a liquid form, if you like, tend to settle out. We're trying to suspend those concentrates, and that's what SC stands for, I guess. Yeah. So what sort of problems do you encounter getting these things off the shelf and getting them through into this thing?
Well, the SCs, the first thing I would do when I took the top off, if there was any different coloured liquid on the top, that would make me think, well, this isn't mixed. Yeah, yeah. Or if you lift it up to the light and you can see different colours down there, that would also make me think, well, this isn't mixed. Yeah. Hence, if you were taking 2.5 litres out of a container, will it be the right percentage of each chemical what's in there?
Yeah, it's a good point. It's a good point.
So
for next time.
For next time.
Yeah. So what you're looking for is something that we know we've got to shake these materials. That's a given. But once you've shaken them, is it? I'm going to use a technical phrase here, Martin. Maybe something that you'd use as well. An homogeneous, well mixed product where the active ingredient is mixed properly throughout the SC formulation.
Equal.
Yeah.
And how long you leave it on the shelf? You know, if you leave it till next year, you know, is it going to settle out, or is it, you know, is it going to work for a year's time?
Yeah. I mean, that's a good point. You've used powders, Nick. Are you fond of powders? Do you see any problems with powders, or do you prefer this sort of SC formulation that?
I prefer the SC formulation, but one thing with powders is if you have a 10 kilo bag and you want 5 kilo out, you know you're going to get 5 kilo of exact product. Yeah. This is what I always think when I'm measuring 5 kilos out of a bag. Well, I know that's right there, but do you know it's right when you're tipping it out of a container?
I guess Martin's the best person to answer that. If you take 5 kilos out of a 10 kilo bag, Martin, is that 5 kilos, is it honour bound to be exactly the same as the 5 kilos that are left in the bottom?
Depends on the granulometry of the thing, like cornflakes packets. When you shake them, the big ones come to the top and the little bits go to the bottom. So if they're not the same particle size, yes, they will separate out. But if it's just one product of the same particle size, yes, it'll be uniform all the way through. And so will an EC, and so will the soluble liquid, phenoxy, because they are clear liquids. So all those formulations will be, yes.
Yeah. And what about dust, Nick? Because obviously, from a powder point of view, you know,
that is a good point actually. With powders, you do get a lot of dust.
Yes. Yeah.
Coming back at you, especially on a breezy day, which you can't always be filling a sprayer in shelter of a building or something. But, with liquid, there's no dust, obviously.
No, that's a good point.
A lot easier.
But I can understand the problem with the SCs. If you've had used half a can, then you go back to another half a can, and then you tip it out and you see you've got a big thick layer at the bottom. Then obviously you're going to wonder if, well, what you sprayed the first time was actually the right stuff or the right amount. So yes, I can understand that. Most SC formulations are pretty uniform because they've got a very low density of the actual product you're trying to suspend. It's pretty low in density, but when you get to manganese, it's 500 or something like that, which is very, very heavy material, it can't defy gravity.
No.
We've got to make it defy gravity.
Yeah. I suppose one thing we haven't mentioned as well, that very rarely, Nick, in my experience as an agronomist, would you just put one product in the tank, and therefore it brings into question, right, I've got products A, B and C, you need to be aware, or you need to be very careful in terms of compatibility, Martin, and that is a big issue on farm where we are putting.
Sure, I mean we are aware. The big guys don't think, the big companies don't think that, you know, they mix their products with anything, we know that, and that you just have to use that and that's all you dare to use. But in reality, the farmer's got, as you say, 7 days to get out there. Yeah. And he needs speed. He needs to get out there. He wants to go out 3 or 4 times a day. Yeah. So it's all time, isn't it? And time is money. So you have to make them compatible so that he can spray more than one chemical.
Are SCs more compatible than... Yeah.
The SCs are more compatible simply because they have less surfactants to compete. ECs are pretty hard. You have to make the emulsion. Soluble liquids are okay, but they tend to be ionically, they have high pHs or low pHs, so that can affect your tank mix. The ECs have a balance of surfactants which can be affected by what you put in, but SCs basically are pretty robust for tank mixing.
That's important.
Sometimes when I open containers and I take the lid off the top, I see different colour of solution as though it's settled out.
Right.
Yeah, I've seen that, Nick, as well. Yeah.
It's not a problem if the products shake. That's an inherent part of the formulation. What happens is we make it and it's all nice and liquid, and then it forms a structure. It turns into a sort of mousse, and in doing that, gravity pulls it down a bit, and it all pulls in together. So some of the liquid, some of the water, if you have it with the surfactants in, sits on the top. If you look at paints, it's very much similar as well. You open a tin of paint, then you see a layer of, and you have to mix in. It's an inherent part of making the structure to keep these things in place. So making the, it's called thixotropic pseudoplastic, but you don't want to know that, do you?
Not really, no. We've got that layer on the top. Is it a concern to Nick? No, it isn't.
Then it mixes in fine, it's not a problem, but as long as, you have to shake them.
Yes, yeah. Is there a technique that you could perhaps, or a little bit of a tip, if you see this, what you're calling supernatant liquid on top, to break that and get that mixed in?
Well, there's a way of shaking it, but I think guys that do it all day shake it properly. It's the guys that come into your lab that don't shake it right, if you see what I mean. You pick up a can of 5 litre can, you shake like that to get the thing moving and shaken up, because you want to get the stuff off the bottom. But if you give it to, say, the layman in the lab, he'll shake it like that, which is no good at all. You've got to get the stuff off the bottom.
One thing that I've noticed though, Martin, over this is the gap that's left between the liquid and the top. You need that, you need room to actually shake it.
If you're trying to break structure, to mix anything, the bigger the volume you're mixing into is much better. It's like a mixing bowl making cakes. You don't have a little bowl, you have a big bowl.
Right, okay.
You have, the area is important, yes.
Right.
Some chemicals, what I see, what I've used over the past, if I see that they are quite solid or got different colours on, I will turn them upside down before I leave. So when I
for the next day,
when I come back, they have mixed.
It's a good technique, that's a good enough technique if you can turn them upside down.
Yeah.
That's a bit of forethought, Nick. That's, hey, pretty impressive.
Very.
The last thing you want is to be left with something on the bottom and think, well, I haven't used it all.
Yeah, yeah, because that might be the important bit that you want in there, I guess. Yeah, yeah. Just in addition to what we've been saying about some of the points that have been raised here, and in true Blue Peter style, we've got something that we prepared earlier in the way of just trying to demonstrate some of the terminology and some of the things that can happen with some of these products. You know, Martin, you use fairly chemist-driven terminology, and we've already mentioned, and Nick, you brought this up as a topic, supernatant liquid, which is the band of material that tends to sit on top of products if they're left to stand a while. And there's two good examples down there where we actually have a fairly dark brown material on top, and then everything seems to be reasonable below it. Martin, I'm assuming that the bulk of that material from the bottom of that line, supernatant liquid, there downwards, is the active ingredient.
That is the active ingredient, yeah. Above that is just water with a bit of surfactant.
Right, okay, so two good examples there. And then in terms of compatibility, one thing that you certainly wouldn't want in the tank, Nick, is this material, which is a mixture of, you said, manganese and a phenoxy like CMPP or something along those lines, and there is a definite demarcation there between something that looks to have flocculated or amalgamated together there, which is a no-no.
Yeah, and basically those two, phenoxy and manganese, should form two clear solutions if dissolved on their own. But mix them together, you get this precipitation.
And does the mixture then become a completely different active?
Well, it's not a completely different active, but you may lose biological control because it's what you form in there is the manganese phenoxate. So they're reacting. So phenoxy needs to get into the plant, manganese will need to get on the plant, but doesn't get in as quickly. So it may delay the active of the phenoxy, so you may
lose some efficacy in some ways. All right.
I don't know. I mean,
and of course that could cause blockages and all sorts of things.
Oh, that as well, yeah. And cleaning out problems as well.
Yeah.